The SETI community has expertise and methodologies for determining whether a potential technosignature is in fact a natural phenomenon or misinterpreted terrestrial technology. When a possible technosignature is observed, we ask, is it a real signal? Is it a known or unknown natural phenomena? Must it be technological? Is it known terrestrial technology? So these scientific communities have relevant experience in determining and communicating about whether observations which first appear to reveal extraordinary evidence actually justify making extraordinary claims. Second, if we do acknowledge an extraterrestrial source, however unlikely, as one possibility for UAPs, then these objects must have traveled through the solar system to get here. Within the scientific community, there's a widespread, but by no means universal belief that there are extraterrestrial civilizations. And we have a well-developed rationale. There's a lot of literature for discussing this, which I won't go into now in the interest of brevity, but it has to do with the vast numbers of exoplanets and the timescales of evolution and the possibility of convergent evolution on different planets leading to somewhat similar outcomes. And it's a fascinating subject, but the relevant point here is that the same rationale which supports the idea that extraterrestrial civilizations may exist and may be detectable also supports the idea that finding extraterrestrial artifacts in our own solar system is at least plausible. NASA is the lead agency for solar system exploration. It already has an active program of detecting objects in our solar neighborhood using both ground-based and space-based facilities, and it could leverage those capabilities to search for objects in space with anomalous motion, anomalous trajectories, unusual light curves, anomalous spectral signatures, or other characteristics. Most of the solar system has not been searched for artifacts or anomalies, and these modest data analysis efforts could potentially be applied to existing and planned planetary missions. The galaxy does not stop at the edge of the solar system, and the solar system does not stop at the top of the Earth's atmosphere. It's all a continuum of possibilities worthy of investigation. If NASA applies the same rigorous methodology toward UAPs that it applies to the study of possible life elsewhere, then we stand to learn something new and interesting, whatever the ultimate explanation is of those phenomena. And that's all I wanted to say right now.
Well, we have time for one or two comments or questions or thoughts.
Yeah. Thank you for that. You know, it struck me while you were speaking about biosignatures that we do a lot of that type of analysis, right, in our home planet in different capacities. And so it's more of a comment, but I wondered your thoughts on, you know, bringing together those communities that might not work together and whether that would aid in, you know, not only establishing what's normal, but enabling the detection or maybe the understanding explanation of a UAP if reported.
Absolutely. I mean, the focus of my talk was observations elsewhere, but in fact, most of what the field of astrobiology has to study is here on Earth, because after all, it's our one example of an inhabited planet, and it's a little bit easier to get to make observations. So yes, any insights you have in that area, or any suggestions for collaboration between those communities would be very valuable.
So, of course, NASA hasn't been researching the technosignature field for very long, and there's been a stigma with technosignatures for many decades. Are there any lessons learned we can impose from the technosignature in the SETI community to the UAP in solar system studies?
That's a really good question. I guess the immediate thought it sparks in me is that, technosignatures were kind of treated, kept at arm's length for a long time by NASA because of stigma, and ultimately can't be kept away forever if you are an agency, curiosity driven, trying to understand the whole universe. You have to move beyond stigmas and just try to honestly look at whatever evidence there is. And so I think in that broad sense, the same lesson ought to apply to UAPs.
As someone who has been working in astrobiology and data sciences for some time now, it strikes me when both Dr. Bianco and you talked that the differences that seem to me between biosignatures and technosignatures fields and the UAP field, again, relies on the data. So biosignatures and technosignatures, they have very well standardized data sets. They have been collecting data sets for some time. And they are able to apply machine learning, artificial intelligence algorithms, while it's a totally different question with the UAPs in how we can apply artificial intelligence here. So again, just like Dr. Bianca, how she said, it's about data standardization. So I hope that the UAP field will learn how to work with the data from the biosignatures and technosignatures fields. So.
Yeah, that's a good point. The one point I push back on a little bit is whether technosignatures has a lot of data in that sense. The one part of technosignatures which is looking for signals from radio and optical and that sort of thing that's been associated with SETI for a long time. You're right. There's a lot of data there that we've been collecting, but the term technosignatures is sort of newly being adopted, and it. In a way, it reminds me of the distinction we heard from the FAA about a cooperative and non-cooperative. That with technosignatures, we're looking. There's more of an emphasis on finding technology that is not necessarily intended to signal us, but just sort of doing what technology does and finding ways to, so it's not looking for signals as much. And in that domain, we have not necessarily been collecting information for that long. But your point is well taken, that there are lessons learned from certainly the astrobiology and the sort of classical SETI field where we've had a lot of data, and we could look at how that is analyzed and try to collect the data for UAPs that will be amenable to that same sort of analysis.
Great, thank you. Colin's next.
Hello, everybody. I'm Carlin Toner. I'm an aerospace engineer. It really struck me when Dr. Drake opened up this afternoon and talked about this really small needle in a really big haystack that we're looking for. And I'm going to talk to you about reporting, a theme that we've heard a lot. How can we make that haystack smaller and that needle bigger? So reporting of UAP events has received a lot of attention recently, but I think that there are still barriers for people to report. How or where should they report? Will someone take action on their report? Will the reporter be believed, or will they be shamed? We've heard over the course of our fact-finding that many scientists and aviators consider the study of UAPs to be fringe at best. So this suggests there's a significant negative stigma associated with reporting or even researching such phenomena. That said, by encouraging military aviators to disclose anomalies that they've seen or detected, the Department of Defense is receiving many more reports. I think in the time that we've been looking at this topic, growing from an ODI report that was something like 500 to, I think this morning we heard something like 800 now, so that's accelerating. And DoD will soon also mandate, if not already, reporting by pilots, which will even grow that set. I would propose to this panel that NASA can help make it safer for researchers to explore data in the civil aerospace domain simply by starting that work internally. NASA could look at how civil anomaly data is shared, study how to incentivize reporting, assess the possibility of crowdsourcing data, which I think we've heard a bit about this afternoon, or sponsor and participate in conferences on UAP detection. Our team has really only seen, I'd say, a few unclassified images of UAP, which lack the contextual data that's needed to understand their true nature.